Okay. I'll be talking about 30 minutes and then the rest of the time for discussion. The paper I circulated for the conference is related to two larger projects I'm working on, and I'd like to start by talking about them. And I'm happy to take questions about either of these broader projects as well as the paper at hand here this morning. First of all, this paper is my contribution to this spring's HOPE conference at Duke on the history of statistical inference in economics. And for the purposes of that HOPE conference, statistical inference means using measures calculated from samples of statistical data to make statements about phenomena not described in the samples. And a familiar modern example of a statistical inference would be a statement about who's likely to win an upcoming election based on a survey of 500 adults eligible to vote in that election. Statistical inference has a history in economics in that there have been changes over time in how economists have made these sorts of data-based generalizations and how they've assessed the reliability of those generalizations. And the conference is meant to illustrate this idea as it features several case studies looking at the inferential methods employed by various economists and groups of economists. And we hope that, among other things, the conference will lead to some useful ideas about what lies behind economists' decisions about inferential strategies. My paper looks at how one particular group of economists, the agricultural economists working for the United States Department of Agriculture in the 1920s and early 30s, approached the problem of statistical inference. Secondly, the paper I circulated reflects a more general interest on my part in the empirical research of these USDA economists of the 20s and 30s. It's well known that they constituted one of the best trained and most able groups of empirical economic researchers in the whole world at that time, and they had access to the amounts of data and resources for processing data that other economists could only dream of. As already noted, in today's paper, I focus on how the USDA economists did inference, what they said about how best to draw valid generalizations from sample data, and how they actually did it. And I hope also to look at how their empirical research methods were changed by the introduction of the New Deal agricultural programs, which suddenly generated a demand for new types of statistical information that were meant to be used immediately to inform very consequential policy decisions. So you might say, why am I interested in how these economists thought about their research and how they did their research? Well, I'd argue that for as long as economists have done research with statistical data, they've had to deal with certain generic questions. I mean, one of those is the inference question. How do we go from a sample of data to a statement about the world that's not in the data? And that's one generic question that any empirical researcher has to answer. But there are others, like what role should the information revealed in statistical data play in theory construction? And how should choices about how to analyze statistical data be informed by theory? And how should researchers deal with known inadequacies in the data? And I think that if we get a solid understanding of how this group of economists at the USDA approach these generic problems, it'll give us an interesting perspective as we look at how these problems are handled by today's economists, by economists at other times and places, and it might help aid us in a normative evaluation of modern empirical practice. So now, turning specifically to the paper I circulated, I'm looking at how the United States Department of Agriculture, the USDA, economists of the 1920s and 30s approached one particular inferential task, which was the creation of crop and livestock forecasts. And this task involved using sample data collected from farmers about what was going on in the farms and the fields at a particular point in time, and using the data to predict the size of the harvest or the number of animals that would be brought to market several months later. And I chose this activity in particular. You'd be amazed at how many different things these economic researchers were involved in, but this is one thing they were involved in. And I chose this activity because the problem of creating good crop and livestock forecasts was almost entirely a problem of applied statistics and involved very little in the way of applying economic theory. Now, as I say, they had other projects where economic theory was quite important, but in this one, it was mostly agronomic, what they called agronomy that informed them, and common sense about how farms work. But by focusing on this problem, I get a clearer view of how economists of the period handled the purely statistical problems that were involved in making generalizations from sample data. There's a companion paper I'm working on where I look at the question of how they use theory in making price forecasts. So in today's paper, I also explain why the USDA believed that making crop and livestock forecasts was an important part of its mission. For one, it was believed that ignorance of the true planted acreage and condition of certain major crops in the field would fuel harmful speculation in the market for those crops. And asymmetric information was perceived a problem also. Agricultural middlemen were believed to be able to obtain privately at least some of the information on the likely size of the harvest or the supplies of agricultural commodities. And this would give them an advantage as they bargained with the relatively isolated farmer. And that advantage could be negated if the USDA could provide high-quality crop forecasts to the farmers. It was also argued that accurate information on likely agricultural output would help farmers operate more profitably. They could shift away from the production of crops that were likely to be in surplus and toward the crops for which demand looked to be high relative to supply. And this argument supported efforts to produce ever earlier forecasts of likely production so as to allow farmers time to change their plans in response to indications of impending surpluses and shortages. In addition, agricultural policymakers worried about what they called the instability of agricultural prices, and a chief cause of such unstable prices was an alleged tendency on the part of farmers to base this year's production decisions on previous year's prices, so that a high price last year led to overproduction and a low price this year. Now, with agricultural prices being an important determinant of the income for a large share of the American population, these price fluctuations could have harmful reverberations throughout the economy. If, rather than reacting to last year's prices, farmers acted on the basis of accurate forecasts of their fellow farmers' initial production intentions, the instability of agricultural prices would be reduced. Now, the USDA had a system for collecting data to make these forecasts, and the system relied on the voluntary cooperation of literally tens of thousands of farmers. And I tell the story of how in the 1920s, making crop and livestock forecasts became the responsibility of a newly created Bureau of Agricultural Economics, or BAE, as I'll call it, within the USDA, and how this bureau in its early years came to be the home to a very technically skilled team of empirical economists. And they went to work trying to improve the forecasts through applying more up-to-date statistical methods. I make 3 points about the crop and livestock forecasting at the Bureau of Agricultural Economics as an example of statistical inference. First, I argue that the methods employed by the BAE economists in making forecasts exemplify a general approach to statistical inference that was shared by the leading empirical economists in the US at the time. Second, I argue that this general approach to inference was much influenced by arguments in John Maynard Keynes' treatise on probability. And third, I note that although inferential procedures employed in making crop and livestock forecasts reflect these general principles of inference, we should also expect them to reflect a special characteristic of forecasting as a species of statistical inference. That is, statistical forecasters often have regular means of checking the quality of their inferences when the actual values of the quantities that they have forecast are ultimately revealed. The revealed reality provides evidence that can be used to improve the forecasting methods. By contrast, an economist who uses sample data to generalize about, let's say, the elasticity of demand for cigarettes will likely never have unequivocal evidence on what the true elasticity really is. Because of the importance of Keynes' views on inference in shaping the practices of how USDA economists did inference, I summarized the views in the paper. One point on which Keynes was emphatic was that statisticians should generally avoid the use of the inferential measures that had been developed on the basis of probability theory. That is, measurements like the standard error of a sample mean. These measures were intended to allow a statistician to take sample evidence, and only sample evidence, and make statements about the world beyond the sample that had very specific likelihoods of being true. So statements like the share of the vote that will be received by candidate X will, with 95% certainty, be between 46% and 48%. Keynes believed there were few situations in which the inferential measures based in probability theory could actually be used in this way. Among other things, the assumptions required for their reliable use were unlikely to be met in the data used by economists. It's worth quoting one of Keynes's summary statements about them. To apply these methods to sample material, unanalyzed in respect to the circumstances of its origin, and without reference to our general body of knowledge, merely on the basis of arithmetic, can only lead to error and delusion. Elsewhere in the treatise, Keynes referred to the statisticians who advocated the use of these inferential measures as mathematical charlatans. The quotation is also instructive because it hints at the nature of Keynes's positive advice on statistical inference. In making generalizations based on sample statistics, the statistician should carefully consider, quote, the circumstances of origin, end quote, of his sample data, as well as his general body of knowledge, that is, knowledge of things beyond the information contained in the sample. More generally, the main theme of Keynes's positive advice on inference was that the methods employed in making inference from samples of statistical data should be based on the logic of ordinary induction, meaning the logic commonly used in making general statements on the basis of empirical observation. For example, suppose we observe several swans, and we make note of their color. In our set of observed swans, we may see what Keynes called a positive analogy, as when all the swans are white. The set of swans also contains a negative analogy. That's the collection of differences across the instances of observation. So some of the white swans are male and some are female. Some are old and some are young. Some were observed in Europe, some in Asia, and so on. As the negative analogy of the set becomes more pronounced, our confidence in a statement based on the positive analogy, a statement like all swans are white, is increased. However, additional instances of observation might lead us to alter our generalization. So if we see a black swan in Australia, we might narrow our inductive generalization to all swans outside of Australia are white. Keynes said that statisticians should think the same way when they were trying to derive reliable generalizations from statistical data. But in place of a collection of single instances of observation on which traditional induction was based, statistical inductions were properly based on a collection of samples, and they involved the numerical characteristics of the groups that generated each sample. 10% of this sample died, or the average wage in this sample was $2 per hour. There would be positive analogies or similarities to be found across the different samples, and there would also be negative analogies. These might be differences in the distribution of the measured variables included in the samples, but also differences in the circumstances surrounding the generation of the sample data. How, when, or where the sample was collected, how the variables were measured, and so on. And along with a careful consideration of positive and negative analogies found in successive samples, we would use our general body of knowledge, including economic theory, to interpret the pattern of statistical results produced by the collection of samples. Now, I offer in the paper several quotations from the USDA economists and from other agricultural economists of the period, showing that their views on statistical inference in general, and the use of probability theory for statistical inference in particular, paralleled those of Keynes. And I've put one up there on the slide. And some of these authors cited Keynes specifically when they were discussing how you should do statistical inference. But more interesting to me than the references to and the echoes of what Keynes said is how Keynes's advice is reflected in what these economists did when it came to making their forecasts and improving their forecasting methods. And in the paper, I illustrate this with extended discussions of two examples of forecasting methods developed by the Bureau of Agricultural Economics. One is the project of forecasting the supply of pigs that would be brought to market, based on farmers' reports of their pig breeding activity several months earlier. And the other is the project of forecasting crop yields at harvest, based on farmers' accounts of the condition of the crop in the field during the growing season. So now you're going to get a brief description of each of these projects, and don't say you didn't learn anything at this conference, because I guarantee you, you did not know this. Now, the pig survey as a source of sample information for forecasting began in 1923. Postcards were put in farmers' mailboxes at the beginning of each breeding season, asking how many pigs had been born on their farm. Remember, these pigs would be fattened and taken to market as hogs about 6 months later. So they were asked how many pigs were born on your farm this spring, and how many pigs were born on your farm during the same breeding season last year. Then averages for the ratio of pigs born this year to the ratio of pigs born last year would be used to forecast the increase or the decrease in this year's hog production. So the pig survey was subject to much analysis and modification by the BAE economists over the next several years. The paper describes one study of the pig survey done by Mordecai Ezekiel and Bradford Smith, and I include it to show how these economists' skepticism about the value of inferential measures based in probability theory wasn't based on an ignorance of how these measures were meant to work. So Ezekiel and Smith took a sample of 8,000 postcards returned by pig farmers in Iowa, and they used them to draw 60 random samples of about 300 each. And then they averaged the ratio of pigs this year to pigs last year for each of the samples. Then they took the standard error formula derived from probability theory to calculate what the standard deviation of these 60 sample means should be if the theory was true. And they found the measure was about half of the actual standard deviation of their 60 sample means. Now their fix for this was, so multiply your standard errors by 2. But they attributed the failure of the theoretical formula to the highly skewed distribution of the ratio, which they could also observe in their sample of 8,000. Then they tested their sample for bias due to non-representative response. For example, what if it was the more intelligent and able farmers that returned the postcards? Well, based on the logic that these farmers would have larger farms, they compared the size of the farms in their postcards to the size of farms reported in the most recent agricultural census. And they found there was little difference, so that wasn't a problem. The BAE economists also sometimes changed the wording of the pig survey when sample irregularities suggested that certain words and phrases might have a different meaning in different regions or might confuse some farmers. Oh, so you missed that slide. Earlier, I noted a special measure of forecasting as a type of statistical inference. That is, the ability of forecasters to regularly check the quality of their forecasts and use the information to improve their methods. So the BAE economists had access to an extensive array of what they called check data. That is, estimates of the actual production of a large number of agricultural commodities to which they could compare their forecasts. So first of all, for every 5 years, the agricultural census would be conducted by the federal government, and it would provide information on the past year's production for every farm in the nation. But more timely data was available as well. That's what's talked about up there on the screen, because the government would request this from railroads and slaughterhouses and other firms that processed agricultural products. And so check data like this helped economists working with the pig survey to detect what they called memory bias, or farmers not properly recalling the size of last year's pig production. And also something they called intentional bias, which was a tendency of hog farmers to underreport their production, hoping that a low production estimate would lead to higher futures prices. This led the researchers to switch to using what they called identical farm samples. So that would consist of, say, a group of cards collected in the spring of 1928 about pigs recently born, and then a group of cards collected from the same farmers in the spring of 1929 about pigs recently born. Then the expected change in hog production from 1928 to 1929 on the same farm would be averaged over all the farms. That would eliminate memory bias, and any farmer's intentional bias would cancel out if he had the same intentional bias in both years. In general, I argue that the development of the pig survey that I've just described represents Keynes's canons of inference in action. Suspicion of the probability-based inferential methods led to tests of the assumptions underlying them. Worries about possible problems with the wording of the pig survey reflects concerns with the, quote, circumstances surrounding the collection of the samples. And the worries were confirmed by the examination of successive samples. The analysis of memory bias was facilitated by comparing match samples from identical farms containing both current and retrospective answers to the same questions. And the economist's general knowledge in the form of economic reasoning about how the profit motive might affect farmer survey responses led them to adjust their conclusions drawn from the pig survey samples in early years and eventually to investigate and try to correct this kind of intentionality bias. Yep, there we go. Now, the second example I examine is the effort to forecast crop yields per acre months in advance of the harvest. When the Bureau of Agricultural Economics was formed in the early 1920s, the USDA crop yield forecasts were made first by asking a large sample of crop reporters to assess the condition of the crops in their areas as they were growing in the fields. And they were supposed to use a numerical scale, rate them 1 to 10 or 1 to 100. Then a sample average of these condition reports would be used to forecast the eventual crop yield. And the way they did it was to assume that the proportion between the actual yield and the average condition number seen this month would be equal to the proportion of the average actual yield over the past 10 years to the average condition forecast in this particular month over the last 10 years. And so those are what those formulas are up there on the slide. And this method worked well enough prior to the 20s that the prices of commodities would respond to the announcement of these yield forecasts. But the technically sophisticated economists at the BAE thought there was a lot of room for improvement. The linearity assumption that was built into this method they thought was not quite right. The method didn't account for unusual years that might be included in the past averages, and so on. So they developed something they called the dot chart as a tool for improving the forecasts. Oh, come on. Okay, that is a dot chart. Now, that dot chart was meant to forecast the yield per acre of the winter wheat crop in Ohio, based on condition reports on the 1st of May. I'm just going to pause for a moment and ask you to contemplate how much work was involved in this endeavor. Winter wheat for Ohio. There was a chart for every state that grew winter wheat. How many commodities were we making forecasts for? 50, 60, 70 commodities. This was being done every month. Okay, that's a lot of work. Just, I want you to appreciate how much work this was. Okay, so this is winter wheat in Ohio, and they're doing it every month, right? And each dot on the horizontal axis, you have the May condition report for Ohio for a particular year. Each dot represents a different year. And in the actual average yield per acre is on the vertical axis, and that was gained from looking at the check data I talked about. So the forecaster could add whatever lines he wanted to the dot chart. The dot chart came to him with dots on it. And on this particular chart, there is a straight line that represents the proportionality formula that I put up on the last screen. And then there is a curved dotted line. Okay, that was drawn freehand based on the more recent years of data in case the relationship might have changed. And then there's a curved dotted line up there in the northeast, and that corresponds to observations from dry years when a dry growing season. And elsewhere on the chart, the wet years have been labeled. So if the current spring was a dry one, the forecaster might take his chart and shift up his forecast that was based on, he'd start with the solid freehand curve, and then he'd shift up because it had been a dry year. Now, I argue that what you see on this dot chart is, again, an application of the Keynesian ideas on inference. Note that the dot chart embodies the use of successive samples to make inferences. Each dot is the evidence of a different sample. The freehand line represents the positive analogy. It summarizes the statement of the average condition yield relationship revealed by the samples. The chart notes one difference in the circumstances under which the sample is generated, that is, the moisture conditions in the spring, dry year, wet year. That's what we call a negative analogy in Keynesian terms. And the choice of which of many possible negative analogies one should consider is based on our general knowledge that comes from outside the sample. In this case, agronomic knowledge of precisely what weather conditions or other conditions are likely to affect the condition-yield relationship for a particular crop. Now, my discussion of the pig survey and of the dot chart forecasting method, they give you a flavor of what you'll see in the way of technical minutia in the 50-page paper that I circulated here. And you'll also see how the economists tried to account for the boll weevil infestation and how bad it might be in a particular year. And if you like such detailed accounts of statistical economists at work, as I do, you will like the paper. Now, I'm going to close on a somewhat speculative point. I've mentioned Keynes's distrust of inferential measures based in probability theory, and I show that those measures played little role in the inferential procedures of the BAE economists. But this stands in stark contrast to the central role that such measures play in statistical inference and economic research in the last decades of the 20th century. In this later period, the comparative analysis of different samples drawn from similar populations, which was an essential part of inference at the BAE, seldom appears at all in the inferential arguments made by post-1970 economists. On the other hand, the inferential measures from probability theory, the confidence intervals, the t-tests, they are central to the argument. Now, a point I make in the paper, and I want to emphasize again, is that these differences I've just noted are not a matter of presence versus absence. The BAE economists did sometimes employ probability theory, and the empirical economists post-1970s did occasionally make comparisons of estimates from similar samples. What I'm talking about here is a difference in emphasis, in opinions about what steps are considered essential to making good statistical inferences and what steps you take only under special circumstances. The question is then, what determines this pattern of emphasis? And I suggest that because of the nature of their research task, the BAE crop and livestock forecasters really weren't losing much when they took Keynes's advice and de-emphasized the use of probability theory in inference. They knew that they would be able to repeatedly apply the same forecasting methods to different samples taken from different universes, and that the potential existed to improve their methods by comparing their forecasts to reality. It made sense for them to place emphasis on the development of better check data and to make the comparative analysis of results from different samples a central element of their forecasting research. Now compare this to the situation of researchers who can't expect observed reality to provide them with regular and trustworthy signals of the reliability of their sample-based measures, and for whom the collection of sample after sample after sample from a similar universe is a very costly endeavor. For researchers subject to these constraints, the promise of inferential measures derived from probability theory is a very attractive promise, because it promises the ability to say, on the basis of information from one sample, that the true value of a quantity estimated with the sample data was almost certain to fall within a particular range. It's a wonderful thing, okay? And so, reporting that kind of range along with your sample estimates would become routine for economists facing such constraints. The development of procedures for obtaining samples that met the required assumptions to justify the reported range would be given a very high priority. And so too would theoretical research on how such ranges could be calculated under an ever-widening set of assumptions about the characteristics of the sample and the universe from which it was drawn. And these trends, of course, are important general features of the development of empirical economics in the second half of the 20th century. And I'm done.
Start over here with Adrian. Thank you very much, Jeff. It's an interesting talk. So my question's with respect to Keynes's treatise of probability. So, I mean, this book is kind of divided into two main sections, right? The latter half is statistics, but the first half is his philosophy of probability. Mm-hmm. My question is, to what extent this is cutting in and out. To what extent do the agricultural economists that you describe, do they buy into his philosophy of probability, specifically with respect to the logical view of probability as a relation of partial entailment between propositions? And to what extent do they also reject the principle of indifference that Keynes is famous for attacking in Treatise of Probability?
They don't appear to have been interested in that part of the book.
Okay.
What they talk about is are the sections on inference and on the use of probability-based measures. And the rest of it, they don't have much to say about.
That's just fabulous. I was remembering with Jeff that how Zvi Grilica said that he came to the United States to do agricultural economics because that's where the data was. And that you have to tell students that the Journal of Farm Economics was the center of empirical economics for a long time. But something the picture reminds me of something, and that is that, and I don't know whether I haven't read your paper, so I don't know if you've put it in, but Stanley Jevons was famous for pushing leastsquares. But both Sandy and Steve Stigler have pointed out that he never used leastsquares. What he did was he would estimate the coefficients simultaneously with the functional form. So it's something like a subjective box-Cox. So what your folks are doing is they're getting estimates of the coefficients, but they're actually their freehand is getting a different functional form, and so that the paradigm of what estimation technique they're working with may not be so much leastsquares as something like box-Cox. We're estimating the functional form simultaneously with that sort of thing, and that's one of the. I hadn't even thought of that until the picture, and that may be one of the powers of doing things like this is you can come to understand what the functional form looks like from the data. And I think but your paper is just fabulous.
I'm so glad you brought that up because the whole methodology at the Bureau of Agricultural Economics in the 20s and the late 30s, they followed a guy named Mordecai Ezekiel who wrote a book, Methods of Correlation Analysis. But the method they used, they called curvilinear regression. And I'll just be very brief and you'll know what I'm talking about. So fit the least squares line, plot the residuals, draw a freehand curve, calculate the least squares differences, plot the residuals, adjust the freehand curve. So when I told you before about how much work this involved, I hadn't even mentioned that yet. Okay, but that was the central method, and they all used it, and they developed shortcuts for it, and for 15 years, agricultural economics literature always investigated the possibility that curvilinear regression with these freehand drawings might be more appropriate. Always check for linearity. Now, it's a very interesting paper to be written, and I'm old and tired, so somebody else can write it. But what happened to curvilinear regression and why? There are lots of reasons you might say we don't want to use this. There's lots of reasons you might say this is better. You know, of the people in the 1940s and 50s, rising computational power is probably important. You know, the ability to use the computational power to fit quadratics, cubics, quartics, but somebody write that paper, please.
Okay.
No, they don't mention Jevons.
Well, I think this is a really fascinating paper. I must congratulate to bring something new to the table, which is not something that you get very often. So I really enjoy this paper, particularly because I think he fill some gaps in our knowledge of how, things in economic history of thought, economic theory, you can do things from different angle. I have 3 points. You mentioned the influence of treaty to probability. I haven't read your paper, so I gather that you're talking about throughout the late 20s, 30s, because of course Trade to Probability was published in 1921. So I wonder how early it got to America, as it were. And so that's just an information, because I would not expect that the book would have been read so quickly. Second point, more interesting, is that, as you know, Keynes wrote statistical memoranda. Volume 12 of the collected writing by Keynes is about the memoranda he wrote for 7 years on commodities, and the section on wheat is very extensive. So what would be interesting to see the reverse effect, whether he would trust these statistics when he was making his own prediction of crops. And so that would be my first suggestion, to have a look at this, as to check the relationship between what his influence on these statistics and how he used the statistics that were made available to him. In his paper, I found a lot of USDA bulletin that he was consulting regularly because he was a regular investor in wheat markets. And this is the second point. This is a research I've been doing in the last 10 years on Keynes as an investor, and wheat was one of his main commodity. Okay, so that would be a further way to look into the matter, which I suggest. But finally, this is a question, genuine question. You said rightly that all the statistical effort were in the hope and the expectation that they might have an influence on stability of prices of commodities, right? I have seen work done on future markets in the 20s and the 30s, and how these data were used to in the future markets as a way to figure out where the premium was like to be and so forth. So I wonder whether you have any evidence of the relationship between these statistics and what was happening in the future market, which at that time was being regulated, the 20s and 30s, precisely on taking care of this. But really excellent paper. Thank you very much.
Well, thank you. First question: How did Keynes' views come to America? Perhaps the leading empirical economist in America as of 1919, 1921 was named Warren Persons. And in his presidential address to the American Statistical Association, I think it was 21, he quoted Keynes extensively on the topic of probability-based inference. The group of people doing sophisticated work with statistics in America was small, and they communicated very well. By 1925, 3 textbooks on statistical methods that were introducing the newer learning were published in the United States. One by Frederick Mills became the leading textbook. All 3 treated statistical inference in the Keynesian manner, some with extended quotations from Keynes or from the Warren Persons presidential address. So it happened pretty quickly. The third question, they understood that futures markets, these people understood that futures markets were in a sense reflections of the knowledge and information of market participants. They wondered, and they were confident that they wondered whether, and they were confident that they could do better. And so they would compare their forecasts to the future. Here's our forecast of the March price. Here is the March futures price. They would generally say they had done better. Now, this was a bigger problem with price forecasting. Price forecasting was a thorny, awful problem, but they tackled it confidently, okay? They really thought they were going to do this. And then they kept being disappointed. Oh, well, we didn't expect this disease to break out in the pig population. We'll get it next time. But so I haven't gotten as far along in that paper as I would like, so I wish I could tell you more. But I will be able to in a year and a half.
A colleague of yours, I can't remember his name now, even if it was a friend, John Birdell?
Oh yeah, John Biddle.
Yeah.
He wrote a really nice paper about whole brick working.
On grain future markets in the 20s and the 30s. Have you seen that?
Yes, and whole brick working was not in the Bureau, but he was part of this larger group, and he was the one who was more insistent that futures markets could not be bested by mechanical formulas.
Very nice paper,
Yes, I would second your recommendation of that paper.
Yeah, Jeff, like your presidential address, this is a great piece of work. You've done some really great archival work, and
thank you.
I really enjoyed it. I had 2 specific questions for you. One that is suggested by something that Christina said. So the first is there evidence that Keynes knew that these empirical economists in the BAE were influenced by him? any correspondence with him about this? Any evidence that he was aware of his influence on them?
I know that he corresponded with persons, but I don't know beyond that, and that's something I haven't looked into, but I should.
Yeah. The other one is takes the influence the other way. When Keynes got into his famous controversy with Tinbergen about the kinds of statistical inference that would be used in the second half of the 20th century that would come to dominate, did these researchers pay attention to that controversy? Do you have any evidence of that they noted it, said anything about it, responded to it?
I couldn't cite a specific thing. I know that in general, they were sort of ambivalent about the developments because on the one, and Henry Schultz, who wasn't at the BAE, but is a really good example of this. On the one hand, the promise and the technical sophistication was very attractive to them, and Frederick Mills as well. It was sort of wouldn't it be wonderful if this could work? You know, if we really could do this.
Absolutely.
But on the other hand, they retained their skepticism. And so you see in the book, you know, as Frederick Mills, for example, revises his book, you see, you know, there's one chapter where he's saying, you really shouldn't do this. But then there's another chapter, and he actually does it in a paper. I mean, does the hypothesis, the Fisherian hypothesis testing. So there's a real ambivalence here about these new methods coming in because they're slick and shiny and exciting, but they have retained this old skepticism. And another writer who illustrates that is Schultz himself, or Henry Schultz, who in the 20s is saying, don't do this, you know, don't trust these confidence intervals. But in the 30s, his summary volume before he dies contains these sorts of statistical tests. So there was a real ambivalence as the transition was going on.
Thank you.
Jeff, I enjoyed the presentation. I'm thinking about these postcards, and the impression I got was that the economists themselves distributed the postcards to the farmers and then collected them themselves. Is that what happened? What was the state of postal service to rural parts of the states at the time?
Okay, by this time they had instituted something called rural free delivery.
Okay,
And
so it was
but it was done by the post office. The Secretary of Agriculture made an arrangement with the Postmaster General, and actually the Postmaster General came to him and said, well, the story is they were riding together in a carriage, so you can imagine this, and the Postmaster General said, can we do anything to help? And so, now there were instructions on how they should be distributed. You know, you were supposed to try to be representative in how you set them out. And you were supposed to meet the farmer face to face, but that really never happened. They put the card in the box one day, and then they came back around the next day and took the card out of the box. And
They being the economists.
no, the post.
The postal service.
But there was this, so they would bring it to town, and then people in town who were voluntarily helping the Department of Agriculture would assemble them. There were there were representatives, and there were some paid people, but it was like, and then a few paid people here, and then on it goes to Washington. So it was a vast volunteer effort. Month after month after month.
So, Jeff, there's an early chapter in the history of development economics, still largely to be told as far as I can tell, that relates very closely to agricultural economics. During the 40s and the 50s, the US philanthropic foundations were already doing a lot of work related to agricultural economics all over the world. In the case of Brazil, for instance, that's why what came to my mind hearing you talk. There were actually graduate programs in agricultural economics that were created before the graduate programs in economics generally conceived. So these are actually kind of two parallel stories. They developed pretty much, as far as I can tell, according to their own logic. So what I was wondering is whether some of the same traits that made agricultural economics particularly suitable to that kind of statistical analysis also made them, or at least contributed to make them, more readily exportable as part of the toolkit of these experts that are starting to rove the world in the immediate post-war.
I wish I knew more about that. I can say a couple of things. One thing is, this is, I wish I could remember the name, but this is an idea advanced by another author, is that, so many of these agricultural economists that I'm talking about, they entered government service in the 20s, and they were working under the sort of Herbert Hoover technocratic view of how government could make markets work better, which was to gather and distribute information. And then private actors, if given full information, would make better decisions, and this would make the economy operate more effectively. But as we moved towards the Depression, they were getting a little more frustrated with this, that it might not be working. And then the Depression comes, and they pretty much buy into the New Deal approach to agriculture, which is that there has to be a lot more explicit control of farmer behavior, or at least incentivization of correct farm behavior that's embodied in the in the New Deal farm policies. And so they were, politically they were progressive. Oh, and this is a point to make. Agricultural economics in America in the 20s and 30s was development economics in a sense, because the perception was that the agriculture sector was the underdeveloped sector of American life, and that there was something called the farm problem, which meant that the people in the agricultural rural areas were poor. They were viewed as somewhat backward in their behavior. Although these agricultural economists respected them as intelligent decision makers, they thought the main problem was lack of information, and that was a problem that they could help to remedy. But so it kind of was development economics in the United States, because there was a constant worry about the backwardness of America's rural areas and how it might be addressed. Two things happened after World War II, and that is that the sort of progressive vision of the government's involvement in the farm sector was becoming less dominant in American political thought. This is somebody else's thesis, not mine, and I wish I could remember the name. And it made involvement in international agencies more attractive, because the international agencies, like the UN and related bodies, were still embraced this New Deal idea of the relationship between the expert and the people who needed to be helped. And so that and you can see the migration of these American agricultural economists into these international agencies, where they then went forth and helped others in other parts of the world. So that's what I can say. All I can say, A, that agricultural economics in America in the 20s was sort of America's development economics, and B, that there's reason to believe that these people wanted to migrate into the international agencies to continue to do on the international stage what politically they were no longer able to do in America.
Well, pending no other questions, I will...
I just want to add that you might have known that Keynes made prediction on pigs. He was a pig farmer as well.
Oh, okay.
And he made prediction on pigs. And one of the discussion with Rafa was about the price, what was going to go to the bacon price on the basis of... So, it just is a little aside, but since you bring in the pig in, I thought I might mention.
It bears a mention.
Yeah, that's great. Well, thank you very much, Jeff, and let's...